All right, good morning, you guys. Today's Tuesday. It's October 6th. Like I mentioned to you guys yesterday, we're going to spend today and tomorrow really recapping and reviewing linear equations, okay? Equations that have x and y in them, two variable equations, and everything that goes along with it. We're really not focusing too much on the actual graphing aspect of it. You guys will probably remember that the actual act of graphing was a pretty small part of the quiz. It was more so writing the equations, okay? And I'm gonna apologize if this sounds bad, but there's really only one way to explain this, okay? This isn't the kind of topic that I can take multiple different approaches to. There's not a lot of different ways to accomplish the same thing. There's really only one way to do this, okay? And so I'm going to really try and emphasize that, but it's going to sound exactly like it did when we were going through it the first time, okay? I think the big thing for us right now, especially for those of you guys that are going to be doing a retake quiz, is you got to experience what the first Algebra 2 quiz looks like, okay? And I think some of us were a little bit underprepared for it. At the time, so hopefully we take advantage of this opportunity to kind of clarify things and really embrace, like, what do I need to be able to do on the quiz itself. All right, so we're going to kind of dive in here. I've got kind of just a bunch of examples that we're going to work off of, and I'm going to try and really emphasize, again, it's going to be the same stuff that I talked about before, the same stuff that I explained the first time through, but that's, like I said, that's just because there's not a lot of different ways to explain this. It just sort of is what it is. It's one of those things in math where this is just how you do it, and I know some people struggle with it. Some people catch on to it quicker than others, but ultimately it just kind of is what it is. We have to be able to do this. It's going to be something that keeps coming up throughout the year, so we just have to get to the point where we can kind of do it, okay? So you could see here it says writing linear equations. I got a whole bunch of different stuff. I got 4 different examples. Example number 1 is basically writing a linear equation for a line that has a slope equal to -2 and a y-intercept equal to 4. Okay, and then on number 2, you'll notice I give you slope just like I did in number 1, but then I give you its x-intercept instead of its y-intercept. We're going to talk about the difference there. Number 3 gives you the slope of the line and then a point that it passes through. And then number 4 gives you a pair of points that it passes through. So again, I understand right now, for some of you guys, you're good with this, you're ready to move on. But what I really have to try and do here is get everybody to a certain point before we actually move on. So I know I'm slowing a couple of you guys down right now. Just bear with me here. Kind of tough it out for the next couple days here, and then we'll be ready to move on by Friday, okay? So here's what it boils down to in a real simple nutshell, cutting out all the extra and all the fluff from it. This is what an equation in slope-intercept form looks like, y equals mx plus b, where obviously the m and the b get replaced. So if I just replace them with 2 random numbers here, if I replace, for instance, the m with a 2 and the b with a 3, this is an example of a slope-intercept equation right here, y equals 2x plus 3. So that's what they need to look like, okay? That's what our answers need to look like on the quiz. They have to have a y, they have to have an x, and they got to go in this order. The letter y, then the equal sign, then the x term, and then the constant, the number all by itself at the very end, okay? So that's what they need to look like. But again, we talked about this. This is the form you're going to use 90% of the time. This is point slope form. So if you look, point slope form has an x and a y, it's got an m, so I'm going to show you this, all right? This is what an example of an equation written in this form looks like. It starts with the letter y just like this, but then it might go like -2. Then the equal sign, then the slope, so I'm going to just use a half for the slope, and then a parenthesis, and then an x, and it doesn't have to say minus, it could be plus, so it could be like +4 right here. So what we're going to do, and you're going to hear this over and over and over again, you've already heard it over and over and over again, which is why some people are good and ready to move on, and some of us need to really bear down here and fight kind of the boredom and really grab hold of this. How do we get from here to here? Because this is what our answers need to look like, but 90% of the time, they're going to start out looking like this, okay? And then here you can see this is generically, I just have two generic points, x1, y1, this is 0.1, and then x2, y2, this is 0.2, okay? So just kind of a bunch of stuff up here, but basically the big thing I want to impress upon you guys is, and I want to just restate it, what do we need every time? Okay, so on these problems where the directions ask you to write the equation in slope-intercept form, if the directions say write the equation, we're actually going to start on problem number 3 here. I just threw a bunch of examples, but as I'm kind of talking here, it just sort of lends itself to doing number 3 first. Number 3 is, for us, going to be the most direct problem we have in this example because we're given the slope and we're given a point. That is what we need. This is called point. Make sure you guys can see this here. I just got to check my camera. This is called point slope form. Point slope form. So, again, if you have not really embraced this, you need to embrace it right now. This is what you need every time. You need the slope of the line and a point that it passes through. If you have these two things, then you have exactly what you need to get an equation that looks like this, that can then be converted into an equation that looks like this, okay? So just follow me here. What we do is we start with the letter Y, okay? Every one of these, we're not going to replace the letter Y, we're going to start with the letter Y. And then after the letter Y is where we put the opposite of our Y coordinate. So you look here, it's Y1. Well, Y1 comes from this idea. If you have your first point here, your Y coordinate is the second number. So after this letter Y is where you plug in the Y coordinate from your point. In this case, it's a positive one. So this is where we just need to remember that minus sign is really an opposite sign. So you have this, or you had this on the quiz itself. You'll have it on the retake quiz to work from, right? The formula goes Y and the opposite of the Y coordinate. So Y in this case, -1. Then comes the equal sign followed by the slope. And again, the slope in number 3 was given. It's 2/3. So there's that. And then from our skeleton formula here, there's a parenthesis and the letter X. So there's my letter X. And then after the letter X is the opposite of the X coordinate. So my X coordinate is a +3. I need to put -3 in there. Okay? So again, I know we're being very repetitive here, but I'm going to be very repetitive so that you see that every one of these, even though they're a little bit different from one another, 90% of them are going to be handled the same way. You're going to plug in the Y coordinate, the X coordinate, and the slope. From there, you're going to always do the same thing. This is the good news and the bad news about the quiz, you guys. The good news is once you get this process down, it's the same thing over and over and over again. So as long as you can do this, you've got most of the work down for the quiz. Now, the bad news is the exact same thing. It's the same thing over and over and over again. So some of us went into the quiz not fully functioning or not fully understanding how to do this, and it really bit us because it is that same process over and over and over again. Okay? So the way that we go about this, because again, our equations need to look like this, Y equals, so we need to get the Y by itself on the left-hand side, but we also need the right-hand side to just be the two separate terms, the X and the constant. All right? So the way that we get that is we obviously start by distributing here. We distribute 2/3 into the parentheses. We get 2/3 times X is 2/3 X. And then +2/3 times -3 is a negative. Well, we talked about this on yesterday's video. When you multiply 2/3 and 3 together, the 3's are going to cross cancel and you're going to be left with just the 2 up top. So it just becomes -2. Okay, that worked out perfectly. The 3's canceled perfectly. Bring down my Y -1. Now again, this side looks the way it's supposed to. It's an X term and a constant. All I have left to do to get it to look like a slope-intercept equation is to get rid of the -1. So obviously we get rid of -1 by adding 1. Okay, at that point it's Y equals, bring down the 2/3 X, and then add the two constants now. -2 plus 1 is -1. That is what a slope-intercept equation should look like. 2/3 x minus 1 on the right side and y equals on the left-hand side. Okay? So again, the key to being able to do this is recognizing that you need to plug the slope and the point into this formula right here. Point slope, y minus y1 equals m times x minus x1. And then you put bars over the equal sign and you convert from point slope form to slope intercept form. Okay? For number 4, there's an extra step. For number 4, you have the 2 points, okay, which means you're going to get to pick one. I'm going to pick this one right here because the numbers are just slightly smaller. I'm going to pick that point to do the same thing I did up here with the 3, 1. But before I can plug it in, I need to know what the slope is. So this is when we use our slope formula, y2 minus y1 over x2 minus x1. Okay, and again, on our quizzes, I saw some of us still struggling with just this basic slope formula. It's y2, so the y of the second point, which is -2, -2 minus the y of the first point, which is 1. So -2 minus 1 over the x of my second point, 3. This is point number 2's x-coordinate, 3, minus point number 1's x-coordinate. So here's point number 1, its x-coordinate is -2. I'm going to move my work down here. On top, -2 minus 1 is -3. On the bottom, the double negatives cancel. It becomes 3 plus 2, so 5. And then, unfortunately for us, that does not simplify into anything nicer, but that just means our slope is -3/5. At this point, now we're right back to where we started on number 3. We have a slope. We just found it right here. So now we have a slope and a point, and this is where, again, things get repetitive. And if you struggled on the quiz, it's because you need to really embrace these next steps. You plug in the slope and the point. The way we do it is always the letter y, followed by the opposite of the y-coordinate. So the y-coordinate in this point is 1. We put -1. Then comes the equal sign and the slope. -3/5 is that slope that I just calculated. Then in parentheses, x and the opposite of the x-coordinate. So go back to your point. Your x-coordinate is -2. We put +2. So there's point slope form. Bars go over the equal sign, and we go through the same exact steps to convert this, okay? So we distribute to get rid of parentheses. -3/5 times x. That's -3/5 x. Unfortunately, this next part's not going to be nice. -3/5 times 2. It's not like example number 3 where they're going to cross cancel, because if you do this, if you do 3 over 5 times 2, meaning put it over 1, 2 over 1, there's nothing that's going to cross cancel. So literally, it's going to be 3 times 2, which is 6, over 5 times 1, which is 5, so 6/5. Okay, but we're going to turn that into a mixed number. So that would be, again, 6 over 5, but we say 5 goes into 6 one time with 1 left over. So it's 1 1/5. And the only really thing to remember here is it was a negative times a positive, so that's a -1 1/5. So you're not always going to get nice round integers for your y-intercept, but that's okay. Last step is the same as it was up there. Add 1 to both sides. You get y by itself. That's what slope-intercept form has to look like. Bring down your slope, -3/5 x, and then -1 1/5 plus 1. Well, the -1 and the +1 basically just cancel to 0, but it's not just -1, it's -1 1/5. So you actually still have that -1/5 up there. And that is totally okay to leave like that. You can have fractions or mixed numbers, okay? Now I want to get done with these last two in the next just couple minutes here, okay? No matter what you're given, you need to be able to find a slope and a point. Those are the two key pieces, because you got to be able to plug in the slope and the point, okay? So when we look at the other two, when we look at the last two examples, number 2 gives you the slope and an x-intercept. Okay, so what I'm kind of gonna run out of room here, so I'm gonna bring this down here. Even though I don't think we ran into this on the actual quiz, I don't think there was one of these on the quiz. Again, for number 2, it gives you the slope is a half, but then it gives you the x-intercept is 4. Well, if you just simply, and we did one of these when we were actually going through the assignment, if you just stop and think about this, the x-intercept is the point where a line crosses the x-axis. So like if you were to draw the x-intercept, you'd put a dot on the x-axis, even though we usually don't do that because we're usually dealing with the y-intercept. But if you really embrace and think about this, what that is, all you have to really do to this is turn it from saying the x-intercept is 4, write that x-intercept as an ordered pair. That's the ordered pair over 4, so x-coordinate of 4, and then y-coordinate of 0. It's the ordered pair of 4, 0. And again, I don't think there was one of these on the quiz itself, but it's a super simple thing to do. You turn this into a point because every single time you have to have a point, okay? So no matter what, that's exactly what we have to have. We have to have it written as the slope is this and the point that it passes through is this. If it gives you the x-intercept, if it gives you anything other than the y-intercept, you have to figure out a way to turn that into a point so that you can plug it in. From here, we do the same thing we were doing up here on number 3 and on number 4. You plug them in. So you go the letter y followed by the opposite of the y-coordinate. Well, in this case, the y-coordinate is 0, which is nice because it doesn't have an opposite. So it can be y plus 0 or y minus 0. Then comes our equal sign, followed by our slope. So the slope I just plug in is 1/2. And then in parentheses, it's the letter x followed by the opposite of the x-coordinate. So the opposite of positive 4 is negative 4. And for the third time in a row, all we do is put bars over our equal sign and convert it to slope-intercept form. Meaning, get rid of the parentheses. So distribute here, it works out real nice. It's just 1/2 times x is 1/2 x. And 1/2 of negative 4 is negative 2. And the added nice part about this problem, even though it's kind of confusing sounding when they tell us the x-intercept, the added nice part is this. When you have y plus 0, you don't actually have to subtract 0 to get rid of 0. You can just say the 0 goes away. So this saves us an actual step because, like I said, we don't have to add or subtract to just simply get rid of it. Okay, once we do both of those things, we distribute to get rid of the parentheses, and we say y plus 0 is equivalent to y. All we're left with right here is a slope-intercept equation. Y equals 1/2 x minus 2. Okay? So, at this point, all right, if you look, here's the answer to number 2, y equals 1/2 x minus 2. Here's the answer to number 4, y equals negative 3/5 x minus 1/5. Here's the answer to number 3, y equals 2/3 x minus 1. They all sound the same because the answer needs to look the same. Okay, and I know I've mentioned it a couple times, but I'm going to mention it again. The reason some of us really struggled on the quiz is because this is historically something people struggle with. The unfortunate part is it was also over half of what was on the test. So some of us really struggled because we kind of took the approach of, well, I'm just probably not going to know how to do that kind of problem on the test, but hopefully I'll know how to do enough other stuff. Well, there wasn't enough other stuff. Okay, so this is something that by Thursday this week, when we do the retake quiz, and for those of you that still have to take the quiz, just be aware there's a lot of this kind of stuff. Writing slope-intercept equation when you're given different stuff. The only time that we handle this any differently, the only time that we don't focus on needing the slope and the point is when we're actually given, remember this is called slope-intercept form. M always stands for slope, but B stands for the y-intercept. The only time we do this differently is when we get something like number 1, which we don't get very often. All right, there was, I believe, one of them on the actual quiz though, where it gave you the slope and it gave you the y-intercept. So literally, this is the one time that you plug directly into y equals mx plus b. Okay? You write your equation the way it's supposed to look. Y equals, m is where you plug in your slope. So my slope is negative 2. So there's my negative 2x, my coefficient in front of x. And then after x, if you're given the actual y-intercept, you can plug it in. So my y-intercept is positive 4. I just put plus 4. That is the rarity Okay, that is the rare instance where you get your actual nice looking slope-intercept equation directly from the given information. All other cases, you plug the slope and a point into point slope form and you convert. Okay, so that should kind of simplify things. Hopefully it kind of makes a little bit more sense. The only last thing that I do want to mention here in this last like minute or two is just the whole aspect or element of graphing these things. Okay, so I'm just going to real quickly draw these. Okay, draw a couple coordinate planes here. 1, 2, 3 up, 1, 2, 3 down, 1, 2, 3, 4, 1, 2, 3, 4. Okay, in graphing any one of these, the thing you want to remember is that they all are very repetitive. Once you get them into slope-intercept form, and by the way, this is why we spend so much time getting things into slope-intercept form, is so that it is always the same work. Once you get these into slope-intercept form, the graph is easy. -2 tells you the actual y-intercept, so the point where it crosses the y-axis, which is the up and down axis. So it crosses at -2. There would be -2 from the origin down 2. And then from that point, we use our rise and our run. So for this example here, number 2, the one I'm going off of, my rise is 1, my run is 2. So I rise 1, meaning go up 1. I run 2, meaning go right 2. So one more time, it's up 1, right 2. So from this dot, up 1, right 2, put a second dot there, draw your line, okay? Showing a couple more of these. If you look at, let's pick one that's going to fit on here again. If you look at number 3, it's got a y-intercept of -1, so I put a dot at -1 on the y-axis. And then I rise 2, run 3, so up 2, right 3. So from here I go up 2, right 3, put a dot there, and draw that line. And then the last one I want to mention is this one right here, number 4, because it had that ugly y-intercept of -1/5. That's not a problem. You just put a dot at -1/5, which would be just below 0. So here's 0. I'd put a dot just below it at -1/5. And then my slope is negative. So this time I go down and to the right. So I would go down 3, right 5. Put a dot there. And then draw in my line for that one. Okay? So again, I know, you guys, that this is going to end up being a 23.5-minute video here. I know that is a lot of stuff condensed into 23.5 minutes. I get that. But like I said before, I think most of us have really kind of grabbed hold of the idea that things are going to be a little bit probably tougher than we initially thought. Okay? We're going to have to get some clarity, some clarification on our questions, and we're going to have to go into quizzes and tests knowing what we're doing. Winging it is going to not really be an option for us, okay? So let me know what kind of questions you have. If you have questions, email me. Ask your classmates for clarification. We just really have to approach this a little bit differently for Thursday, okay? Especially if you're going to be one of the people that I'm asking to do a retake on the quiz, because I really don't want people starting in a dramatic hole early on, okay? All right, guys, I'm going to wrap it up here. You guys make sure you send me your questions if you have them, and get working on this worksheet. I kept it relatively small just so that we'd only have a little bit of practice problems each day, but I do want you guys to have just a little bit of practice as you get ready for either your first crack at the quiz or your retake of the quiz. All right, guys, have a great day, and I will talk to you later on if you have any questions. Bye.